about HACCP principle number 2, which is determining critical control points. So as you remember, the previous chapter we discussed in detail how to go about conducting a hazard analysis. Now, as a result of the hazard analysis, we're going to then take the information that was an outcome on, in particular, the significant hazards identified and look at what control measures have we identified, and out of those control measures, which ones are now going to be absolutely critical to our operation. So for each step with a significant hazard, we have to absolutely run those through a CCP decision tree. So where we've identified a significant hazard, we're then going to take it now and evaluate whether or not the control measure we have is good enough, or whether we need to identify it as an absolutely critical step or a critical control point in our process. So let's talk a little bit about controlling hazards and the HACCP methodology approach. So we're going to look at some definitions here. So we talked about the definition in the previous chapter of a control measure. Now the definition of a control point is similar, but it is any particular step in which a biological, chemical, or physical factor can be controlled. So this is more pinpointing a specific step. A control measure is quite a bit of a more broad definition, which can be prerequisite programs, it can be good manufacturing practices, or something that's applied to the site overall. For example, if you're applying control to potential pest hazards or hazards coming from rodents or from birds or from stored product pests, that would be an example of a prerequisite program such as pest management, pest control, being a control measure to the facility overall. Now, a control point may be something, for example, like a magnet at a particular step that's controlling for ferrous metal only at that step. So that's a control point. It may not be absolutely critical for the success of our system in our HACCP based risk reduction system, but it is there at a specific point in order to apply some sort of control of that hazard. Now, as we look at this a step further in terms of what is absolutely critical to make sure that those hazards don't occur, we get into the definition of critical control point. So critical control point can be defined as a step, and this is a specific step, at which a control measure can be applied and is essential to prevent or eliminate a food safety hazard or reduce it to an acceptable level. So keep in mind that the word essential is really the difference and the decision maker here compared to a simple control point. It really makes sure that there's an elevated amount of attention given to focus on the prevention, elimination, and in most cases reduction to an acceptable level of those hazards that we've identified as significant. So we want to make sure that there again we are preventing the hazard. In some cases, if it can't be prevented or eliminated, we will have to reduce it to an acceptable level. Okay, so those are our three focuses of, or goals, if you will, in terms of the outcome we want that critical control point to achieve. So we've used the term control a lot, right? And definitely in the food processing industry, it's our job to make sure that certain controls are applied for the safety and sometimes obviously the quality of our products. But in the case of HACCP, we want to focus there again on what is absolutely critical for the safety to make sure that we don't have any outbreak scenarios or we aren't causing harm to the customers and consumers. So what is control? Well, control may be that correct procedures are being followed in the case of prerequisite programs. and that established criteria are met, right? So that's part of the definition of control. We also, in order to ensure that's happening, we have to manage conditions of the operation to ensure compliance with the procedures or with the expectation. So in the end, control basically means that whatever expectations we put in place up front, or the established criteria, to use that term, we want to make sure that those are being consistently met. And as long as we can ensure and verify that those are being consistently met, we will have that much more validity to our system to make sure that the desired outcome is the safety of that product. Other key points to remember is there may be many control points in a process, but there may be a lot, and typically there are a lot fewer critical control points. Okay, so the control points may control a portion of a hazard, or they may be combined to control a hazard at multiple steps, whereas critical control points are really, we're really narrowing it down to one specific step in which a control of a biological, a physical, or a chemical hazard can be applied. CCPs are also based on the output of the hazard analysis, and we're going to get into some examples of using the CCP decision tree, which is a tool that the Codex Alimentarius Committee and the NACMEF Committee has put in place for us to use as part of this principle number 2. So there is a standard template to be used here so that we can justify our decisions and determine the outcome of whether it's just a control point or a critical control point. Examples of process critical control points. Critical control points may be in the form of pasteurization. So when we look at that, we're looking at a potential of a certain temperature for a certain amount of time. And that scenario to control a biological hazard is always going to be a point of reduction, right? We're reducing the count of those pathogenic organisms to a safe level. That's in the nature of pasteurization and its definition of a 5-log reduction in the count of those bacteria. Remembering back to our chapter on biological hazards and what we learned there about their controls. Another example of a critical control point, in particular in the reduction of, or in this case maybe the prevention of, pathogenic or biological hazards, would be acidification. So that's lowering the pH. Typically you want to target a pH of 4.6 or below with the product formulation to make sure that additional growth of any microorganisms cannot occur, in particular those nasty hazards, pathogenic biological hazards we're trying to eliminate or prevent or reduce to a safe level. Okay, so in some products it could be the product formulation, such as looking at water activity, moisture levels that help control for biological hazards. In some cases they may help control for chemical hazards as well. In the case of allergens and labeling conditions. So overall there could be many examples that we could talk about for hours of process critical control points, depending on the types of products that you produce and the nature of the process itself. So let's look at another example. We're going to look at the example of pathogenic E. coli and Salmonella on raw vegetables. So the goal here obviously is to provide some sort of control, and in this case we want to provide a control that's critical to the reduction of E. coli and Salmonella on raw vegetables. We may not know what the end product is going to look like. In this case it could be a canned product, it could be a individually quick frozen freezing process of the raw vegetables. But if we were to look at what would be the most consistent and the most effective control for those biological hazards, would it be the supplier certificate of analysis, which would kind of indicate a level of sampling and testing? Well, potentially, but maybe not, because we know we can't test our way out of preventing pathogenic organisms from being there in the first place. So sampling and testing in its nature is just a verification activity. Would it be something like refrigerated storage? Well, refrigerated storage, in particular on raw commodities, could slow or potentially stop the growth of E. coli and Salmonella, but you may have it there in the first place coming from the field. Would it be making sure that the storage and the handling of that product is done in a sanitary environment? Well, yeah, that could further prevent hazards like environmental listeria or environmental Salmonella from the plant environment cross-contaminating the product that's going down the line or during storage and handling process. However, it still is not going to do anything if E. coli and Salmonella are present on the raw materials or the raw vegetables in this case coming in from the field. So we would say that your best option and a place to start, obviously that's going to reduce, consistently reduce the amount of E. coli and Salmonella down to a safe level on those raw vegetables, would be heat treatment. So in this case, if it was something like a canning operation for those raw vegetables, or a freezing operation, or even a refrigeration operation, if you could blanch them or treat them up front, you're going to have a lot more success with controlling those hazards. And in this case, something like that kind of a treatment would be considered a type of pasteurization or a critical control point in its nature. So that's just one example of how critical control points can be determined. Now we're going to get into some of the methodology, so other critical control point considerations. So how do you designate critical control points? There's not really any wrong or right way. The HACCP methodology just requires that as you go throughout the hazard analysis, you have to define them in a way that's understandable and that makes sense. So some operations will put CCP number 1, CCP number 2 as they go throughout in determining their critical control points they have in place. Others will put CCP P1, CCP B1, CCP C1 in terms of designating what type of hazard that critical control point is controlling, such as a chemical hazard, or is their first identified biological hazard or physical hazard. Others will put the actual process step or the actual equipment, such as CCP oven, CCP packaging, but in the end, there's no wrong or right way to designate critical control points. Obviously, you just want to make sure that it's clearly understood by everyone that may evaluate your food safety and HACCP plan, and most importantly, so your employees that are enforcing, executing, implementing, verifying those CCPs on site have a clear understanding of what's needed to control and effectively implement those CCPs. How many should a operation have? Well, the answer is as many as is necessary, right? It's going to depend on the result of your hazard analysis. That's why we can't take a boilerplate template and just apply it to your operation. You really have to go through the process of knowing the details of your ingredients, raw materials, utilities, all those inputs, but also knowing where they come into play in your process in every detailed step of your process, right? So it's really dependent upon the type of the product, the ingredients, processing methods, and how well implemented and applied your existing prerequisite programs are. So those all have a factor in determining whether or not you need a critical control point at a certain step. So the answer to how many critical control points should a company have, well, it's really as many as is necessary to make sure that those hazards have been prevented, eliminated, or reduced to a safe and acceptable level. Okay. Other considerations to take into account are the product's intended use. Remember back to our 5 preliminary steps of the HACCP method. One of those steps, right, step number 2, was determining the intended use and distribution of that product, right, in the product description. So we want to make sure we know how it's going to be used by our customer, which consumers are going to use that product, right? That may have a determination on whether or not a critical control point is needed. Also, another factor is make sure that we are following regulatory guidance and requirements in some cases, such as juice HACCP, meat and poultry HACCP, seafood HACCP, and FSMA regulations. So talking about regulatory requirements and considerations and guidance from either the Food and Drug Administration or the USDA. Some examples here, when we talk about juice HACCP, that regulation includes at least one CCP needed for those type of operation, and that is for the reduction of vegetative pathogens. Okay, doesn't say they have to have metal detection, doesn't say they have to have physical hazard control. According to FDA in that regulation, they say if you're processing juice, you have to have a valid pasteurization or kill step for pathogenic organisms. Okay, the reason they may not include other hazards such as physical or chemical is that obviously there's been outbreaks as a result and recalls as a result of pathogenic contamination in juice products that FDA and that our industry has learned from past outbreaks and scenarios. So the rest of it really is dependent upon the supplier to customer relationship in terms of what physical hazards need to be controlled. In some cases, juice operations may not be packaging juice down to the consumer level. Some of them may just be packaging in drums or in bulk tankers. So their customers may want some sort of foreign material control, and most have that in place. However, it's not absolutely critical and applicable to every single juice operation in the eyes of the Food and Drug Administration. There are other regulated programs such as canned foods and low acid canned foods. Shelf stable juice are not required to have a CCP because of the nature of their process themselves. Like we've talked about throughout the training for products covered by the FSMA preventive controls, CCPs are typically referred to as process preventive controls. Other types of preventive controls may also be required, such as allergen preventive controls, sanitation preventive controls, and supply chain preventive controls under that rule. However, FDA never states in that rule that a critical control point in particular or at any given step is absolutely always required. So we would have to refer to the methodology in that regulation to determine whether or not we have preventive controls for FSMA in addition to our HACCP critical control points. So now, once we've determined our significant hazards using our principle number 1 of hazard analysis, we're going to get into how do we go about answering the question of whether or not that significant hazard and a particular step to control that hazard is critical in our operation. Okay, so this leads us to using the Codex decision tree. So Codex decision tree, as you can see here, it's a set of 4 different questions. Okay, each question subsequently goes through whether you answer yes or no on to the next step in determining ultimately whether that particular step controlling that hazard is a critical control point or whether or not it's just a prerequisite program or simple control point. So observations from the decision tree. We're going to look at sometimes what you'll find, and when we go through these 4 sets of questions, we'll find that a subsequent step in the process is more effective than the step we're evaluating. And that's perfectly fine. I mean, the point is to make sure that that significant hazard is controlled somewhere along the process before it leaves the products, the finished products, leave your facility. If a hazard is identified which cannot be controlled, then the process may need to be redesigned or designed in a different way, or potentially the product reformulated depending on the outcome of the CCP decision tree. If a process is specifically designed to control a hazard, it's often going to be a CCP, but it depends on the nature of the hazard and that particular step, and like we mentioned earlier, whether or not there are subsequent steps that control those hazards later on in the process. So let's take a closer look at the decision tree. And we're going to get into an example here coming up, but just to review the 4 questions and how we would use this tool. So question number 1 is, you're going to take a significant hazard at a particular step and you're going to ask the question, and this is something your HACCP team should go through as a whole for any of those significant hazards. And another important point to remember about this, or that I should point out, is a record should be kept of going through this process of answering and showing your answers to each of these 4 questions. But to get back to the questions, question number 1, do control measures exist for the identified hazard at that step? Then we move on to question number 2, is the process step specifically designed to eliminate or reduce the likely occurrence of a hazard to an acceptable level? So keep in mind, we're talking about the process step, one step at a time, in particular when we use this tool. Question number 3, could contamination with identified hazards occur in excess of acceptable levels, or could these increase to an unacceptable level? So this is, in and of itself, could the hazards identified increase so that they are no longer in safe levels? And the last question is, will a subsequent step eliminate identified hazards, or, like I've used the term many times, reduce the likely occurrence of that hazard to an acceptable level? So with each of these 4 questions, there's going to be a yes or no answer, and it's going to take us in a path that helps us determine whether or not a critical control point is necessary at a particular step for the safety of the product. So like I mentioned earlier, we're going to look at an example now of how you would use this tool. So in our process, say we have identified a physical hazard of metal. Okay, that may come in with the raw materials. It may be introduced as part of an equipment potential failure, or a lack of maintenance on the equipment, or the shedding of metal from a screen, or a metal-to-metal contact. Wherever that hazard may occur within our process and within our raw materials we are using on site, we're going to identify metal as a significant hazard according to our hazard analysis. Now, every place we've identified it as a significant hazard, we need to then take the CCP decision tree and run that hazard at that particular step through the set of 4 questions. Doesn't always mean that all 4 questions will be answered. In some cases, you may stop after question number 1 or question number 2. Really depends on the nature of your process, and obviously based on the questions that you first start to answer. At a minimum, you're going to have to answer question number 1 and show your work for each specific step where a significant hazard has been identified. So back to the example, metal detector. We're talking about the metal detector step. So we are going to ask the question, do control measures exist for the identified hazard? Well, yes, we have the detection of metal within that step. So we have a device that is detecting metal at that particular step. So our answer to question number 1 would be yes, measures do exist for the metal hazard at this step. So now we move on to question number 2. Is the process step specifically designed to eliminate or reduce the likely occurrence of a hazard to an acceptable level? So for the metal detector, yes, if it's a properly validated, properly verified metal detector, it's reducing metal, in this case, down below 7 millimeters in size, or maybe even smaller to meet certain customer specifications. And it can consistently control stainless steel, non-ferrous, and ferrous metal types. We've covered all the potential metal hazards that can be controlled at that step, so we can answer yes. This process step specifically is designed to eliminate or reduce the likely occurrence of a hazard to an acceptable level. And in this case, a metal detector is not eliminating metal. Of course, it's going to reduce it down to a certain sensitivity of detection. So if we answer yes here, you can see that as we follow the chart, we end up with metal detector being determined as a critical control point. So in other words, if it was not there, there's a potential for harm to occur when the customer or consumer eats our final product. Okay, so now let's look at another example. And in this case, this is dealing with a biological hazard. So it could be pathogenic E. coli, salmonella, or listeria. And it could be in a juice product or a fluid dairy product, for example, such as milk. Whatever the case may be, we're looking at the specific step of pasteurizing or applying some sort of time and temperature to the product at this step. So we're going to ask ourselves question number 1, which is, do control measures exist for the identified hazard at this step? Obviously, we're going to answer yes. There is a certain amount of control. We don't yet know whether that control is absolutely critical to the process, but that's something that you would have to know with the nature of the product, what your expectations and outcomes and goals for those outcomes would be with your process. Now to question number 2, is the process step specifically designed to eliminate, or in this case pasteurization would absolutely reduce the likely occurrence of the hazard to an acceptable level? So just like the metal detector example, we answer yes, which takes us down that if this is the last step in which this would occur, to control the hazards, and in this case biological hazards, pasteurization would typically almost always be a critical control point. So now let's look at a little different example. We still have a metal detector, but this operation in particular has a set of 5 metal detectors within their process. So in this case, we're talking about the second metal detector. So we're going to ask ourselves question number 1, do control measures exist for the identified hazard? Yes. That metal detector is still applying some sort of control. Question number 2, is the process step specifically designed to eliminate or reduce the likely occurrence of a hazard to an acceptable level? In this case, we know about our process that no, we have further subsequent metal detectors downstream, so our answer would be no, this second metal detector of 5 is not specifically designed to reduce metal in the product overall. And in some cases, maybe there is additional equipment, dicers, slicers, other metal equipment after the second metal detector before we even get to the third metal detector, and so forth and so on. So therefore it won't absolutely reduce metal, or it can't be assumed that all metal will be controlled at the second of these 5 metal detector steps. So now question number 3, could contamination identify the hazards with the identified hazards occur in excess of acceptable levels, and could these increase to an acceptable level? Like I said, if there's other equipment in between, then the answer would absolutely be yes. Now, this takes us to our 4th and final question, and this is going to be the deciding factor, is will a subsequent step eliminate identified hazards or reduce it to a safe level? Well, obviously here we kind of know this as part of our process. This is only the second metal detector out of 5, so therefore, yes, a subsequent step, which would be another metal detector, is going to eliminate or further control those hazards downstream. So you can see here the CCP decision tree has led us to an answer of this step, the second metal detector, is not a CCP, and we're done with the process at this point. Now this may mean that we need to still make sure there are prerequisite standard operating procedures in place for each of our metal detectors in this case, but only potentially one of them is absolutely critical, which would be your last metal detector in this case on a single line setup. So now let's look at another example that may not be as straightforward. So this one has to do with a magnet, and a magnet on a product line. It's meant to control, and the hazards we've identified are all metal types. So we're looking at ferrous metal, non-ferrous metal such as aluminum, copper. Doesn't mention anything about stainless steel in this particular scenario, but there is not a metal detector inline or downstream in this particular scenario. So we're going to ask ourselves question number one: do control measures exist for the identified hazards? Well, no, not really, because what we know about most magnets is typically they are an earthen or are only going to control for ferrous metal, not for non-ferrous or stainless. So in this case, we can't say that control measures exist for all metal types. So this is going to take us to a scenario is that is control, and another set of questions that's within this question number one, or a subset, is control at this step necessary for safety? Well, yes, if we don't have a metal detector downstream, we need to make sure that that product is free of all metal types. So in this case, if we answer yes, then it's going to take us to a scenario where we have to modify the process step or modify how we process this product overall. So you can see here that if there's an absence of a control method for a significant hazard, it's going to lead us back to a scenario where we modify our thinking and may have to introduce additional control measures for those significant hazards. Another example, pathogens in raw bulk commodities, and we know our customer will pasteurize later. So we are just maybe just processing in bulk, and it's a work in progress type product where we know we are not going to be the end processor of this product. Our customers, and we've identified this in our product description and intended use with the preliminary steps for HACCP, we've said this product is bulk. It's not intended to be sold or consumed directly by a end consumer. So this means that we're going to rely on our customer to take care of the biological hazard in this case. So our question number one is no, we do not have any control measures at this particular step for controlling those hazards. And is control necessary at this step? Well, if we already know we are not claiming that this product is ready to eat or ready to consume, our answer to that question is no in this case as a subset to question number one. Therefore, it leads us to not a CCP, and ultimately we're done at that step. So this is an example of where we have to understand a little bit about our intended use of our product and why we set that up front in terms of our description, our intended use, and what we know is going to be done with that product. So every operation, of course, is different, and it has to be uniquely documented in that case for each process. So now we're at the point of wrapping up or finishing up our hazard analysis. We're now looking at using the CCP determination tool or the CCP decision tree to ultimately answer the questions in column 8, which is this step a CCP or preventive control for FSMA, or is it not applicable? So as we could see in our example here for almonds, the pasteurization at a later step will be a CCP. In this case, to control for salmonella. For the metal, we're going to have metal detection at a later step in the process. And for the non-significant hazards, columns 7 and 8 are really not applicable because we've already stopped at the prerequisite program side. So one final consideration in determining CCPs is a control cannot be operated as a CCP unless it is effective as a control. So what that means is we have to make sure that we are using a valid process. Okay, so for example, if we're talking about dry roasting of almonds, a process with only a 1 log reduction cannot be a CCP because it does not meet the regulatory requirement. If it's in the case of juice, it would require a 5 log reduction to be considered pasteurization. Anything less would say that it's not effective in reducing the count of those pathogenic organisms to a safe level. Okay. Other steps, such as a hand sorting step to eliminate foreign materials, those are very difficult steps to validate, especially if you've got different employees. They have a different set of eyeballs that they're looking at the product with. Well, how are you going to validate that? There's too much variability there. And we're going to get into talking more about this particular subject as we get into the principles of HACCP, discussing verification and validation for your CCPs. Another example would be, say, like a wash process for washing fruits and vegetables without having enough data to demonstrate it's effective in reducing the count of microorganisms on that product coming in and being washed. So there's going to be other scenarios we have to consider in terms in particular of validation and how we're going to verify a critical control point step in our process. We'll consider those as we get into further chapters within the methodology of HACCP. So in summary, for HACCP principle number 2, which is determining critical control points, we have to keep in mind critical control points are absolutely necessary, and those steps where it's necessary to control a particular hazard, right? We're focused on either preventing the hazard, eliminating, or reducing the hazard to a safe level. Keep in mind that not all organizations or that process and manufacture food or all facilities will always have a critical control point. It really depends on the nature of their process and their product and what they're doing with that product. So nevertheless, each facility has to go through the process of determining whether or not a CCP is needed for those critical or significant hazards identified in their hazard analysis. You also have to show your work. You have to make sure that you're justifying your decisions. And one tool that we talked about in this chapter is using the CCP decision tree, or the Codex Critical Control Point decision tree, as a way of making sure that we're effective in determining whether just a control measure can be applied versus whether or not it has to be a critical control point. Keep in mind that a process step can only operate a critical control point if an effective control measure can be introduced. So effective means that it's effective in preventing, eliminating, or reducing the hazard. It has to be a valid step, okay, such as pasteurization. We talked about the examples of metal detectors. We talked about controls for maybe product labeling for allergen. All those would be examples of valid, effective steps in controlling hazards. And lastly, the HACCP plan must be reviewed regularly, and the CCPs must be evaluated based on any changes and reevaluated if there are any changes in equipment, the processing data that is being collected as a result, or if there are any concerns for food safety.